Okay, my friends, we are talking about the mole here, and we're going to introduce something about how much a mole weighs, talking about the mass of a mole. If you want to follow along with me, I am in 10.2, which starts in your textbook there on page 325. Are you comfortable that different things have different masses? Your textbook gives an example of you wouldn't expect a dozen limes to have the same mass, to weigh the same amount as a dozen eggs. Even though the number of them are the same, you would have different masses. They'd weigh different amounts. The same thing if I had a dozen trucks and I'm putting them together and comparing them to a dozen cars. They're different amounts of material in them, so they'll have different masses. So the same thing goes with a mole of something. If I have a mole of limes, they'll be different in weight than a mole of eggs. Again, remember that's an awful lot, but the masses would be different. And there's no difference if we're comparing different elements. That if I have 1 mole of carbon, it's going to have a different mass than 1 mole of hydrogen. If you were to look at the periodic table, you would see that there's a significant difference in the amount of the atomic mass between carbon and hydrogen, 1.008 to 12.011. So when we're talking about the amount of mass that 1 mole of something has, we actually use that atomic mass that's given to us there in the periodic table. So these numbers here that are on the bottom of each of the squares of the periodic table, those tell us how much mass 1 mole of that substance has. So if I have 1 mole of carbon, using that periodic table, I know that that 1 mole of that substance is 12.011 grams per mole. That's meaning 12.011 grams is how much, if you took 1 mole of carbon and put it on a scale, it would weigh 12.011 grams. So we use the units grams per mole to show in 1 mole I have 12.011 grams. Same thing if I go over to hydrogen. That hydrogen, since it's a much smaller element, right, only just 1 proton and 1 electron, it has a mass of 1.008. I kind of wrote over that a bit, sorry to not let you be able to see that, and maybe if I were to zoom in a bit more you would see that as well. Well, anyway, it would be 1.008 grams per mole. And again, what that's telling me is if I have 1 mole of hydrogen, again, 6.02 times 10 to the 23 atoms of hydrogen, the mass of that number of hydrogen atoms will be 1.008 grams. And so we can use this, what we call now molar mass. The molar mass is simply the mass in 1 mole of a substance. And again, how do we find that? We use the periodic table. The atomic masses that are given for each element will tell you how many grams of that element are in 1 mole. So we can use that molar mass to make a conversion factor. Just like we did going from moles to atoms, or moles to particles of some sort, we can use this conversion to go from moles to grams. Your textbook on page 327 gives an example of you buying a whole bunch of jelly beans and you don't want to actually count each individual jelly bean out. You instead take and find out that 1 dozen jelly beans has a certain mass. So the example they give you is that 1 dozen jelly beans equals a mass of 35 grams. So therefore, if you want 5 dozen jelly beans, right? Customer comes in, they want to buy 5 dozen of these jelly beans. Well, I can use this conversion factor to find out what should the mass be. I'll make my same skeleton, and I would have that 1 dozen jelly beans equals 35 grams. So basically, I'm just multiplying these two guys together. 5 times 35, of course, will give you 175 grams of jelly beans. So therefore, now we've used this conversion, an amount, 1 dozen, and a mass, to transform something from an amount to a mass. So if you measured out, 175 grams of jelly beans on your scale, you would know that, hey, this is 5 dozen jelly beans. So we do the same thing when we're using molar mass to convert from an amount of an element to how much that amount actually weighs. So if I have 0.0450 moles of chromium, and I would like to know, please, how many grams of chromium does that make? Well, again, I'm going to take this number that I've been given, 0.0450 moles of chromium. I'm going to put it in my skeleton. Of course, my units are always going to go down here, so we're going to know that moles of chromium go here, and I want to get to grams of chromium, right? That's my units that I'd like to end up with. So how do I know what's the number that goes in this conversion factor? I'm going to go back to my periodic table, and I'm going to find chromium, and chromium is right here on that periodic table. Let me erase these other lines that I've put up and about here. So 51.996 is the molar mass of chromium. If you look there on that square, 51.996. So therefore, I'm going to put that number as grams. 51.996 grams are in 1 mole. Because again, the units for molar mass are grams per mole. In 1 mole of the substance, that atomic mass tells you how many grams are present. So I do the math. Your textbook rounds and uses 52.00, but we want you to actually use the number in your periodic table. When you do that math, we end up with 2.34 grams. Is that correct? Yes, 2.34 grams of chromium. Notice I have 3 significant digits, and that's because those 3 are significant. The 4, 5, and that final 0 at the end are significant. So, again, all I did was simply just multiply these two things together. 0.0450 times 51.996. So again, this is for us to go from moles to grams. We can do just the opposite. If I want to go from grams to moles, it'll be the exact same thing, using the same kind of numbers. So if I have 525 grams of calcium, and I want to know how many moles is that? Well, I'll do the same process. 525 grams of calcium. Notice I'm putting my units in the skeleton. Always the units from here go down. So this time grams of calcium will go on the bottom, and moles of calcium will go on the top. How do I know how many grams are in how many moles? Again, I go back to that periodic table, and this time calcium is right here, so 40.078. 40.078 grams in 1 mole. And again, your textbook, because this is an example problem number 3 on page 329, they round. They use 40.08. I don't want you to round. I want you to use the numbers in your periodic table. You do that math. In this case, we're multiplying these guys, and then we're dividing the answer. So 525 times 1 is, of course, 525. Divide by 40.078. So therefore, my answer here is going to give us 13.1 moles of Ca. And that's my answer. Again, 3 significant digits because that's the number I started off with. Pretty straightforward, I hope you see. How do I find the numbers to make the conversion from grams to moles? It's from the atomic mass on the periodic table. That lower number is what will tell you. For ruthenium, this example I just circled there, 101.07 grams of that substance will make up 1 mole. The last piece that your chapter 10.2 shows is that we can use this conversion along with the one we've already used before. So we can go from grams to atoms. And we just have to use both of these conversion tools that we've used so far to make this conversion. So I'm on example 4 on page 330. That if I have 31.1 grams of gold, and I want to convert that into how many atoms of gold do I have? Well, there's no way for me to go directly from grams to atoms. We don't have a conversion to do that directly. So we have to take it in 2 steps. So we'll start off with what's given to us, 31.1 grams of gold. Again, notice I'm using my units. And I'm going to plug in, because I need to get from grams, because of course whatever I have here goes there. So grams of AU in moles of AU. I can't go directly from grams to atoms. I have to go to moles first. How do I know how many grams of gold are in 1 mole of gold? I come here and I look at the PT, and it says 196.967. 196.967 grams in 1 mole. So that cancels out my grams of gold and gives me to moles of gold. But I'm not done. I want atoms. I don't want moles. So therefore, I'm going to use my new conversion. Oh, sorry, this was my new conversion we just taught you, the grams to moles. I'm going to use my old conversion. Again, units from here going down, that moles of AU can become atoms of AU. And what numbers will I put in here? Well, this is Avogadro's number, that there's 6.02 times 10 to the 23 atoms in 1 mole. So in this case, I've used multiple conversions to go from grams to moles, and then from moles, these guys will cancel, and I'm left with atoms of gold. So therefore, I'm going to multiply these guys together, and then divide the 2 answers. So 31.1 times 1 times 6.02 times 10 to the 23, 196.967 times 1, which of course is just the same number, and then divide those 2 answers. When I do that, I end up with the answer of 9.51 times 10 to the 22 atoms of gold. AU, Andrews University, because of course that is the Golden University. A way to check this is, you see this is a smaller number, right? Times 10 to the 22 versus 10 to the 23. And you see that this 31 is much smaller than 200, right? It's 1/6 of that 200. So therefore, it would definitely be a smaller number than a full mole of this atoms. So 9.51 times 10 to the 22. I hope that's helpful for you as we make these conversions from grams to atoms, from grams to moles, and from moles to grams.